Alright, today we're doing some basic tests on a Chevy Traverse 3.6. This has a suspected battery draw problem. I think we already found that and solved it, but I just want to do some basic tests and I'll show you why here. I just want to make sure that this connection right here isn't terrible. It's definitely not good. It looks horrible, but it'll be okay. So we got an amp clamp on the battery negative cable. Here's our scope ground. There's our battery positive connection. And I've got this, so when we get over to the scope, you'll see I've got this set up in the 1 millivolt equals 1 amp setting. So I've got channel 2 on the scope over here and hooked up to the power distribution center so I can get voltage drop when we go to crank this. And I just want to go over a few settings on the scope and then we can get going on this test. So this is the Topdon Oscilloscope. I've got it right now to set my sample rate, which is important. I'm on the 50 10 million setting here under user set, depth, and then you get here. So that's the highest sample rate setting, and we're going to back this way off to about 20 seconds per division, and that's still going to give us an effective sample rate once I start running it here of 50,000 samples per second. And for this test, that's more than enough, so that's what we're going to do. And then I've got, if I click this button here, that pulls up our channel menu, and I can click on each one of these to control the channels. And you can see here that I have the yellow channel and the blue channel, which are both our voltage channels, set up the same here. And you can see how we can move these up and down with these arrows. So I've got these identical, and we've got 2 volts per division, 18 volts on the scale, and then 2 volts below 0. And then our amp clamp, we have this set up, instead of voltage here, we have it set up on current. And then there's some preset leads here, but this is 1 millivolt equals 1 amp, or 1,000 milliamps. So that's the 1,000 times scale. So that's going to be 1kx for this clamp. So we've got that set up, and we've got it on 100 amps per division, and you can see that there per division all the way up. And then we've got 20 seconds per division, so each of these boxes are 20 seconds, which is going to be more than enough time for the test we want to do. So that's how we have this all set up, and I've got my 0 right there for the amp clamp. So we're going to go ahead and hit run. Now our scope's running. I'm going to go start this 2 or 3 times. I'm just going to let it stabilize and then shut it off. Do it again. Let it stabilize again. Sorry about the focus, I don't know what's going on here. I'm going to start it again. Let it stabilize. That's probably enough. So we're going to go ahead and shut it off. Let's go see what we got on our scope. So I want to do this a few times so that way we can heat up those connections if there's any potential bad connections on the scope, or on the between the battery and the starter, or between the battery in this case and the power distribution center up here. So that's just where we're testing. So you can see this is what we have on our scope. So now I can stop it and zoom in, and I can move my zoom box right over here, and I actually want to widen that a little. So there is all of our starting events. So you can see green is current out of the battery, and the blue is the one up at the power distribution center, and yellow is back at the battery. So now if we're going to go to our menu and we go to measure, I already have these selected, but you can see we have minimum here for the blue and the yellow. And you can see those are right there. And you can already see that we may have a problem. We have almost a little over a volt difference between the two at the minimum. So let's zoom in and see what we can see. And because of the heat, I want to check the last one first. And we're going to zoom way in here. And you can see as we zoom in, we do have a significant voltage drop while we're cranking. Now, is that good or bad? We don't know, because we don't have a known good one to test, but that must be good because the engine starts. So we're not really concerned with that amount of voltage drop at, you know, what are we looking at, near 700 amps. I would say about a volt difference is not that big a deal. But say we want to really dial that in, right? So let's zoom in a little more. Then we're going to put our horizontal cursors out. And I'm actually going to select the blue channel. And then we can set our cursor at the bottom of each of these, like that. And then we get our delta, which is the difference between the two, of almost 2 volts. So again, you could decide if that's bad or not. I am going to recommend replacing that battery cable end anyway, putting a soldered on end or a crimped on end, and then bolting it to that terminal, and that'll probably take care of most of that voltage drop. But I just wanted to demonstrate how easy it is to knock out these tests. You know, I'm, what, 7 minutes into this video, and probably maybe 15 minutes into setup and capture, but that includes messing around, setting up to shoot the video and shutting the music off and all that. So you can see this test can be done relatively quickly, and because I have a nice big buffer, I can get 2 or 3 captures in one screen. I can zoom in on them, and I'm going to shut the cursors off. And you can see our current inrush and our battery voltage maintains pretty well through the cranking events. And you can see they're all very similar, and I'm not worried about the battery condition or the starter condition. Everything looks really good. We know we're getting our charging voltage, so we're not concerned about anything else. Now, it does drop kind of low at the blue. You know, if you look at our minimum, we're below 8 volts. But if you look at our minimum on our yellow, which you really can't see very well, we're still well in the safe area, around 9 volts while cranking. So, you know, and again, I've done this, you know, I probably started this thing 3 or 4 times and then did this test. So I know the battery's healthy, the system's relatively healthy, we do have good charging voltage. You know, I'm very confident in this test. So now that I know everything passes, we can set up a data logger, monitor the battery voltage and current draw overnight, and prove this doesn't have a battery draw, and then present the findings to the customer and get them on their way. So that's what we're going to do. But we always want to do these basic tests first. And if I was, say I had a slow crank or something, or some other weird issues, I may take another voltage lead way down in here and find somewhere on the bell housing or on the start or on the engine block somewhere to measure voltage on my ground side of my engine block also, just to make sure my ground cables are all good. But in this case, I'm not really concerned with that. But this is just one of the many ways we use an oscilloscope every day in the shop. And you know, this is a convenient scope to use. This is a really good setup. It does take a little bit of getting used to the user interface, but I'd say it's well worth it, and it's a pretty powerful tool. So thanks for watching. I'll show you next time I have this set up. We'll go over something else.